Okay, so on this unit 7 review, it says, is set A mean less than or greater than or equal to set B? And the standard deviation is the same, greater than or less than. So what you're going to do is you're going to find the mean and the standard deviation. Now, remember, in order to find mean, you're going to add all them up and divide by the number that there is, or the number of dots that there are. And that is the mean, which is the same thing as mu. Okay, so you're going to add all these up. So I'm going to take a calculator because I'm not doing this in my head. Appreciate you. Okay, so I'm going to have 110 plus 15 plus 16 plus 18 plus 18 plus 18 plus 19 plus 19 plus 20 plus 20. And I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 173 divided by 10. And so that's going to give me 17.3 for that first data. On the second one, you're going to add them all up and divide by how many there are. So 10 plus 13 plus 15 plus 15 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20. And we're going to divide by 10. So that's going to be 158 divided by 10. So that's going to give us 15.8. So which one is bigger, set A or set B? Set A. Okay, so set A's mean is greater than B. On the next one, what you're going to do, so we're going to do standard deviation. That's that little circle and then the squiggly thing. So you can go into Desmos and it'll actually do it for you. So if you go in here, it'll actually find the mean and the standard deviation for you. So then you don't actually have to do it in your head. Okay. So coming in here, let's see if I can split screen on this. Let's see if I can do it. One. Okay. So if I hit this little plus sign and I hit table, for X1, I'm going to type in all the numbers that I need. So I got 10, 15, 16, 18, 10, 15, 16, 18, 18, 18, 19, 19, 20, 20. And then I'm going to hit this little keyboard and I can type out standard deviation of X, and it should be sub 1, which I'm sorry, let's do this. Standard deviation of so it would be 2.87. Okay, so for set A, we've got 2.87. Okay, set B, you're going to do the exact same thing. Okay, the only thing is you need to make sure that you clear your list or you start a new list. So remember, when you type out this list, you're going to hit the little plus sign, you're going to hit the table, and then you're going to type out all your numbers into this list. So it'll be 10, 13, 15 3 times, 16, 17, 18, 19, and 20. And then we'll come down here. We'll do ST, DE, BP, parentheses, and we'll type in that X sub 2. And that's 2.79. Okay, so which one has a bigger standard deviation? Set A. So set A has a greater standard deviation than B. Okay. I would maybe use your TI-84 instead. For your TI-84, remember you hit stat, edit, you type your list in. I'll write this down. For a TI-84, you could do stat, oh, not state, stat, edit, type your list in, and then hit stat, right click, and then it's one variable stat test. And then the mean is going to be the mu, and the standard deviation is going to be the sigma x. That's where we typed it into that calculator. You can do it either way on the final exam, but there's definitely going to be a question like this where you compare data sets. Okay. Go ahead and look at number 2, and we're going to go over it in just a second. Working on number 2. Okay, so it says a volleyball team has a mean serve of 532 serves in a season with a standard deviation of 35. If the serves for a volleyball team is approximately normal, about 95% of the data falls between which two values? Okay, so let's go ahead and take a look at it. First, we're going to draw our curve. Our mean is 532, so that's going to go in the middle. Okay, and then we're going to take 532 and we're going to add 35 to it. So we got 532 plus 35, which is going to give us 567. Then we're going to add 35 again, which is going to give us 602. And then we're going to add 35 again, which is 637. I would draw the normal curve completely and then look at it. Yeah. But I see your point. And 672 is going to be that last one. Over here, we're going to take 532 and we're going to subtract 35. And that's going to give us 497 minus 35, which is 462. This curve is really wonky. 462 minus 35 is 427. 1, 2, 3, 4. 35. It's going to give me 392. Okay, so now keep in mind that this would be 34, this would be 34, this would be 13.5, this would be 2.35, this would be 0.15, this would be 13.5, this would be 2.35, and this would be 0.15. So we want 95% of the data. So remember, our empirical rule states that the first standard deviation away is going to be 68%. 2 standard deviations away is 95%. So looking at our range, it would be from 462 to 602. So the data would fall between 462 to 602. All right, so let's take a look at number 3. So we've got z-score equals x minus mu equals the standard deviation. So we're going to take the number, so the value that we got on the test, minus the mean divided by 7. Okay, so we're going to do 92 minus 80 and then divide it by 7. And so that's going to give me 1.71. Remember, you always went around to 2 decimal places on this one, so that way you could use the z-score table. Okay. Okay, so if you type it into the calculator and you do this, 92 minus 80 divided by 7, what you're telling the calculator to do is take 80 and divide it by 7. No, you want the entire thing in the top to be divided by 7. So you got to use those parentheses around there. Okay. Go ahead and, all right, let's take a look at number 4. So the Dodgers baseball team has a mean batting average of 200 with a standard deviation of 40. Assume that the batting averages are approximately normal. What is the probability of selecting a player with an average over 350? So let's go ahead and draw our normal curve. Man, that curve is killing it. Look at that curve. All right, mean average of 200. And then I'm going to go ahead and do the rest of them. So that's going to give me 240, 280, 320, 1, 2, 3, 360, Over here, I'm going to get 160, 120, 80, 1, 2, 3, I think we're supposed to stop 40. So what is an average over 350? Well, 350 doesn't fall on my normal curve, right? So I'm going to have to use the z-score and then use the z-chart. So my z-score formula is going to be x minus mu over the standard deviation. So that's going to be 350 minus 200 over 40. So that'll be 350 minus 200 divided by 40. And that'll give us 3.75. I'm going to go to my z-charts and look at what the number is from there. Okay, so I'm going to pull up a z-score table. And every z-score table is just a little different. And when I say a little, I mean, it'll be like 0.001 off. So it's not a huge difference. Okay, so I'm gonna hit clear all drawings and then I'm gonna put it back up here in a second. 3.75. I'll put it back up in a second. But do you see where 3.75 is on our chart? Is there even an option for that? No, it's like way off, right? So what's the likelihood of that actually happening? It's not happening, right? Okay, because he's like way off the chart. Okay, so it's what? Exactly. I mean, could it happen? Yes. Is it likely to happen? Not really. Okay, so we're gonna say 0% on this one. Oh, that's a sigma, 0%. Okay, or 0.0 or 0. Okay, what's the percent of Dodger players that fall between 190 and 160? Or I'm sorry, 260. So what you're going to do for this is you're going to find the z-score for each of these, then go to the z-chart, and then subtract those numbers. So the first thing I want you to do is find the z-score for both of these, and then we'll go over how to find them from the z-table. Okay, so this is what I got. I got negative 0.25 and 1.5. Is that what y'all got? Okay, so now I'm going to go to my z-table. And first I'm going to do the positive because I have this one already pulled up. So I'll start at 0, 0, and I go down to 1.5 and go over, and that's 0.9332. I'm going to write that down. 0.99332. I know you can't see that yet. It's okay. And then we go to a negative z-score table, and we're going to go to negative 0.25. So we'll go to negative 0.2, and then we'll go over to 0.05. So that's 0.4013. This one right here, negative 0.25. 190 minus 200. 0.4013. All right, coming back to my page. Okay, so I have 0.9332 and 0.4013. So I'm going to take those and subtract those two. So I'm going to get 0.932 minus 0.4013, and that will give me, so again, I put this minus 0.4013, and that gives us 0.5319. Now it said for the percent, so we're going to change this to a percentage by saying 53.19%. All right, the superintendent at a school system wants to know how her teachers feel around the county. County has 2,500 employees. What's the best way to collect data? And what they're asking for here is an experiment, an observational study, or is a survey the best way to collect data from 2,500 people? Survey, because it's feelings, right? It's like, All right, let's look at the next one. What would be the best method the superintendent could use to select 100 people for the study? What do you think? Survey would hit 2,500 people. What about 100 people? Huh?
What's the
The question is how her teachers feel around the county.
Oh, it's the same thing.
I mean, you could do a survey. That's a possibility. Would it be a good representation? Because like maybe the people in like the language arts department are like real happy, and then like the math people aren't so happy.
The one where you change something to get a certain something.
That was very. So we could do an observation. We could like go and sit in a meeting and be like, "Yo, how do you feel about this?" Or, introduce something and be like, "How are y'all's feelings?" You could also do a survey though. I would take either one of those. Okay. Emily conducts an experiment to know the effects of eating a mint candy before taking a test. She selects 10 of her friends to take an exam while having eaten a mint, and another 10 of her friends to take an exam with no mint. How should Emily have chosen her sample instead? She did what? So she picked 10 of her friends, right?
Mhm.
Don't you think her friends might be biased? Like, don't your friends all like the same type of gum as you do? Okay, just me. Okay, never mind. All right. Okay, so she should have picked people besides her friends. Somebody said it. Bias. Okay, because this introduces biasy. Okay. Yeah, but there's some people who are like, yes, mint, and some people who are like, no.
I think people who you're friends with are people who are they're not like you. It's like getting in. So whoever you're closest to.
So who doesn't like gum?
But you're trying to see, okay, but like, let's be honest too. Your friends normally do about the same as you on your exams, right? Like close, like in a range, yeah. Okay. But my thing is, you're just kind of thinking through how should she have chosen her sample instead, trying to take out biasy, trying to. I mean, that's basically
an opinion instead of gum or something. Like trying to gain a certain opinion.
Okay, you're saying change the entire experiment instead. That's a possibility. She needs to make sure that she does a random sample though. That's really the biggest thing, because random sample is going to give you the best results. Okay. All right, so on this next one, it says write out a situation where a survey is biased. Okay, so let's think through it. Huh? What kind of question would be biased?
It would be like, LeBron is going through something and he wonders if the Lakers are the best team in the NBA. He asks his teammates. But you know where it's going, like he plays for the Lakers. So he's asking his teammates, are they the best team in the NBA? Or like a teacher asking her students who the best teacher is.
Right?
That's easy.
Okay, so like asking someone something, having bias. Okay, so like you said, like if I said, okay, who's your favorite teacher? It's at South. And I'm standing right here and I'm asking you the question, obviously that bias. Okay, another one would be if it's kind of like what Hope said, where is it Burger King trash, yes or no? That's like directed towards a specific answer. Does that make sense? Put it in a trash can. Wow. Ooh, Hope Burger King doesn't listen to this. I own no copyrights, it's fine. Okay. Number 8, basketball teams are separated into 2 groups of 10 at random. First group is asked to focus on free throws. Second group is given no special instruction at practice. Wow. At the end of the month, the stats for each of the players are given for free throw shots. The mean for the first group is 35 and the second is 25. The difference of means is recorded below in the histogram. What is the most reasonable conclusion for this data? Is there strong evidence, no evidence, or is the difference likely due to grouping? Okay, so what do y'all think? The mean for the first group is 35 and the second is 25. Now the first group practiced free throws. The second group was given no instructions. So they could practice free throws, they could not. It's asking what's the most reasonable conclusion. So like, why did that happen? It's common sense. Well, yeah, but
this could be, I'm not even sure how
right. So they spent more time on task, right? Okay. Now I do want to have a conversation about this. This said difference of means. Okay. So this is the difference between the two data. So right here, this is the difference between the first group to the second group. Okay. So the difference is really great, right? So is there strong evidence? Is this peak right here really high? Yes. So there is a strong evidence for, hey, if you spend more time on free throws, guess what? You're going to be better at them, right? Okay, but that's what this is showing. That's what this is showing. All right, what is the best way to ensure when picking from a population you get an unbiased and random grouping? Describe the best method. All right, so what's the best method for picking a random unbiased group?
Oh, there was a word for it. I forgot. Dang. Hold on, I know it. Hold on.
So what you would do, like, let's say I want to run an experiment in here. I would number all of my students, one to 10 or 1 to, well, however many there are of you. Number people, okay? And then I would use a random number generator to pull a sample, okay? Now, it kind of depends on like what I'm assessing, because that whole biasy comes into effect, okay? So do y'all remember the different types of sampling that we also talked about? There was simple random sampling, systematic.
Stratified.
Are you looking from a list? Good grief, you got them all. Ooh, so proud of you, look at you. Okay, so what would be the best way? This that I just described would be a simple random sample, okay? So cluster would be like, hey, everybody who likes language arts, go stand over here. Everybody who likes math, go stand over here. And then I would only pull a certain group. Well, that would probably create biases, so probably not the best idea, okay? Systematic would be that I number y'all off and every third person would be in a group. So that would really create some type of random sampling and unbiased, okay? And then stratified would be decent. That would be like, hey, everybody go stand in your group, whether you like language arts, math, science, social studies, and I pull one from each group randomly. So that's a good idea as well. But you really want to focus on setting everybody up in a random order, numbering them randomly, and then pulling a random number each time, okay?